Alright guys, I'm going to do a video here for you for word problems. It's a Unit 8 word problem review, so it's going to have multiple different types of word problems we've looked at so far in Unit 8. All of the problems do have something similar about them, and that similarity is what we're going to focus on, how we can set up the problems and then use that to help us solve it. So I'm just going to walk through a couple different problems for you. The first one is Mike and Morgan are brother and sister. Mike is 6 years older than Morgan. They have a combined age of 38 years. How old is Mike? How old is Morgan? So first, I really like using the diagram to help us out. So we got Mike and we got Morgan. Since Mike is 6 years older than Morgan, Morgan is the youngest, and then Mike is Morgan's age plus 6 years. That's a really great way to visualize it because Mike is the same age as Morgan but 6 years older. And then combined, their ages add up to 38. So if I assign a variable to these, we get an x and an x here. I have my equation as Morgan's age plus Mike's age, so x plus 6, and then together their total age equals 38. Then from there, I've set up an equation that I can solve. And start by combining my like terms. 1x plus 1x is 2x. Then use inverse operations to solve this. Since it's a plus 6, I will subtract 6 from both sides first. I get 2x equals 32. And then 2 times x, so divide by 2 on both sides, and I'm going to get x equals 16. So just be careful with this problem, you're not quite done. X equals 16, and remember Morgan was just the one x, so Morgan is 16, and then Mike is 16 plus 6. So Mike is 22. And then we're done with that one. And then you can always check to make sure that 16 plus 22 does in fact add up to 38. Okay. Ryan has 3 times as much money in the bank as her sister Molly, plus $5. When they put their money together, they have $125. How much does each sister have? So this is a very similar type of problem. We're comparing two things. One has a little bit more than the other. Instead of ages, though, it's dealing with money. But essentially, it's the same setup. So we have Ryan and Molly. Instead of who was younger, we have, since Ryan has 3 times as much money in the bank as his sister Molly plus $5, Molly has the least amount of money. So Molly becomes our original x variable. Then Ryan has 3 times that amount, so it's going to be 3 of those x's for 3 times that, plus he has $5 more. So that means that our total sum together has 125. So that means that we have Molly's money is x, and then Ryan's money is 3x plus 5. And when I combine them together, it has to equal 125. So I'm going to start by combining like terms. 1x plus 3x is 4x, plus 5 equals 125. Then I can solve from here. It's a positive 5, so I'll subtract 5 from both sides first. I get 4x equals 120. 4 times x, so divide by 4 on both sides. 4 divided by 4 is just 1x. Since 12 divided by 4 is 3, 120 divided by 4 is 30. Then remember, we should always ask ourselves what the problem is asking. In this particular case, it's asking how much does each sister have. So Molly had just the single X, so Molly has $30, and Ryan has 3 times that amount, so you can either take 30 plus 30 plus 30, or 30 times 3. Either way you get 90 plus 5 would be 95. So Molly has $30 and Ryan has 95. All right. Terrell, Kevin, and Jaden are all brothers. They're all born 3 years apart. Kevin is 3 years older than Tyrell. Jaden is 3 years older than Kevin. And when their ages are combined, they add up to 45 years. What are the ages of the 3 brothers? So this one is similar to the last 2 problems we did, but it has 3 brothers this time. So we have Terrell, Kevin, and Jaden. So I'm going to use T for Terrell, K for Kevin, J for Jaden. And then remember, we always want to ask ourselves, okay, what's the problem asking us? We want to find the ages of the 3 brothers. Then we ask ourselves, we've already decided that this looks similar to the problems we've done before. Then after we decide what it's asking us, we look for the important information. So they're all born 3 years apart, but what's really important is that Kevin is 3 years older than Tyrell, and Jaden is 3 years older than Kevin. Since Kevin is 3 years older than Tyrell, and Jaden is older than Kevin, Kevin is going to be my youngest brother, so he's going to be my original X variable. Then Kevin is 3 years older than Tyrell. So, I'm sorry. I read that wrong. Start over. Kevin's older than Tyrell and Jaden's older than Kevin. So Tyrell is the youngest. Then Kevin is 3 years older than Tyrell. So same age plus 3 years. Not 3 times, just 3 years older. Then Jaden is 3 years older than Kevin. So we have the X. If Jaden is 3 years older than Kevin and Kevin is 3 years older than Tyrell, then Jaden is actually 6 years older than Tyrell. So that's an important piece to this one. You have the plus 3 more years. And all 3 together, their ages add up to 45 years. So I have Tyrell's age is X, Kevin is X plus 3, and Jaden is X plus 6. If I add them all up together, I get 45 years. I can combine my like terms. X plus X plus X is 3X, and 3 plus 6 is 9. Then I'll start by subtracting 9 on both sides, my inverse operations there. The 3X will come down. 9 minus 9 is 0, so that's gone. 45 minus 9 will be 36. I was adding, not subtracting, so 36. Then, to solve for X, I will need to divide by 3. And 36 divided by 3 is 12. So that means that Terrell is 12, Kevin is 12 plus 3, so 15, and Jaden is 12 plus 6, which is 18. So Kevin is 15, Terrell is 12, and Jaden is 18. And then remember, we can check by making sure that 18 plus 12 plus 15 equals 45. Just to make sure we got the right answer. And then we answered the question. Okay, Tony and Gavin are long-distance runners. They train together and do what they can to get in shape. On a recent long distance run, Tony was running at the rate of 6 miles per hour. Gavin runs a little faster. He was running 7 miles per hour. How far did both of them run after 2 hours? So this one does not look similar to the ones I've done so far, but it does remind me, and it should remind you, of the rate problems, the distance equals rate times time. The thing that stands out to me is the rates. We have a rate of 6 miles per hour, and then we have Gavin running at 7 miles per hour. So this is going to be one of the combined rates problems that we've seen before. So they're training together, and they're getting in shape, so they're running the same way, and we want to know how far do they run after 2 hours. So we have distance equals rate times time for Tony. Then we have plus rate times time for Gavin. So first their distance equals, Tony's rate is 6 miles per hour, so 6t, because I don't know what the time is quite yet. Then Gavin's rate was 7t, and so their distance together will be 6 plus 7, which is 13t. Now it says how far did both of them run after 2 hours. So that means it's telling me t equals 2. Sometimes it gives me the distance, like how far did they go, or how many hours did it take to get 240 miles. Then I would have had 240 over here for distance. This particular problem is asking me to solve for the distance. How far did they both of them run when after t equals 2? So distance will equal 13 then times 2, which will be 13 times 2 is 26, and it was miles per hour, so that means we're talking the distances in miles. So they ran 26 miles together after 2 hours. Remember, this video is pausable, fast forwardable. You don't have to watch the whole thing if you think you got it, but I'm just going to go through a couple more examples. The package delivery company has a central warehouse where they put packages on tracks. 2 drivers fill their trucks and leave in different directions. Senta leaves and heads east on the freeway, going 60 miles per hour. Devon leaves but heads west, driving at 45 miles per hour. How long before they're 420 miles apart? How far will Senta be from the warehouse at this point? So the first thing I ask is, have I seen a problem like this before? I say, yes, it's a rate problem. I've seen problems like this before. Then I ask myself, well, what is the question asking? It actually has 2 questions. How long, so it's asking for a time, how long before they are 420 miles apart? And also, how far will Senta be from the warehouse at that point? Then I'm going to ask myself, well, what do I know? I know that they are leaving in different directions, and I know that Senta's going 60 miles per hour, and I know that Devon is going 45 miles an hour. So this is a problem where they're starting in the same spot, but they're going opposite directions. And Senta is going east, and Devon is going west. And I want to know when the total distance between how far they are is 420 miles. So the distance, this is my distance, equals rate times time for both of them. The rate that Devon is going is 45 miles per hour. I don't know how many hours it's taking him though, so it's 45t. Senta is going 60 miles per hour, and I don't know how many hours he's gone, so 60t. Now see how I've combined these two to get 420 miles? So together this distance equals 420. Then combine like terms. 45 plus 60 will be 105. Then divide by 105 on both sides. And you get t equals 4. Yep, 4. And it was in how long? 45 miles per hour. So since it was miles per hour, this is 4 hours. It takes them 4 hours before they're 420 miles apart. So we've answered the first question. Check. We have not answered how far will Senta be from the warehouse at this point. So for that question, we want to look just at Senta's distance here, just this part. And we have Senta's rate times time equals 60 times t. So her distance, or his distance, will be 60 times t. Well, we found that t is 4, so it'd be 60 times 4 hours. So she's got a distance, or he's got a distance of 240 miles. So now we've checked off that second question as well. So be careful to make sure that you're answering both parts of the question. Okay, similar. Thousands of people travel every day on the train from Washington, D.C. to Philadelphia. It is 140 miles between D.C. and Philadelphia. Train A leaves Philly for D.C. at the same time train B leaves D.C. for Philly. Train A is a fast train and travels at 80 miles per hour, and train B is a slower train that travels at 60 miles per hour. How long before the trains pass each other on their way between the two cities? How far will train A be from Philly when the two trains meet? Okay, so first thing I'm asking myself is, have I seen a problem similar to this before? And I have, because it reminds me of the problems that I've seen before with the rates. So it's going to be similar to those problems. Next, I'm looking for, what is it asking me? First, it's asking me how long before the trains pass each other. And the next thing it's asking me is how far will train be from Philly when the trains meet. So I have two-part question again. This time the diagram is a little bit different because you have one train leaving from DC and the other train leaving from Philly, except for that they are driving towards each other, and it wants to know, when is this going to pass? When are we going to hit this line? So basically, when are we going to complete this distance between the two trains? This total distance from DC to Philly was given to me right here, 140 miles. Then I have train A and train B. I have train A will be rate times time, and train B's distance is rate times time. Train A is the fast train, they're going 80, and train B is a little slower, going 60. So the rate for train A was 80 times t, so 80t, and the rate for train B is 60t. And together, like if you added up the distance train A is going and the distance train B is going, so all together 80t plus 60t, they've gone a total distance of 140 miles. And somewhere in there, they're going to pass, and that's what we're trying to figure out. What time will that happen? So 180 plus 60 will be 140. T equals 140. Then divide by 140, and T equals 1. They were driving miles per hour, so it's 1 hour as well. So the trains will meet on the tracks or cross each other on the tracks right here in 1 hour. That's checked off the first question, how long before the trains pass each other? The second question is, how far will train A be from Philly when the two trains meet? So how far will train A be? So that's over here. This is train A's rate. So train A distance equals 80 t. Train A is R times t. And then the distance after 1 hour, so plugging in 1 for t, 80 times t will be 80. So train A goes 80 miles. And they meet after that. All right, I think this is the last one. I'm thinking of three numbers. The second number is twice the first number. The third number is 4 times the first number. When the numbers are added together, the sum is 70. What are the three numbers? So have you seen a problem like this before? Hopefully it reminds you of Terrell, Jaden, and Kevin, because it's similar. But except for brothers, we have just three numbers in general. So we have number 1, number 2, and number 3. So what is the problem asking us for? It's asking us to find what the three numbers are. What do we know? We know that the second number is twice the first number, and we know that the third number is 4 times the first number. So since they're both being compared to the first number, we also know that the first number has to be the smallest. And then we also know when they added together, the sum equals 70. So we know the first number has to be the smallest. Then the second number is twice the first number, so 2 times as large. And the third number is 4 times the first number, so 4 times as large. And when you add them, three numbers up, you get a sum of 70. So if our first number is our x, then our second number will be 2x, and our third number is 4x, so 2 times and 4 times that amount. So the sum is 70, so that means when we add them all up, it will equal 70. So it's a 1x plus a 2x is a 3x plus a 4x is a 7x equals 70. Divide by 7 on both sides, and you get x equals 10. So that means that my first number is 10. My second number is twice that, so 20. And my third number is 4 times that, so 40. So my three numbers are 10, 20, and 40. And you can stop here if you'd like. There is one more example if you'd like to follow along. 2 electric cars are going in opposite directions. One car is going 3 feet per second, the other car is going 5 feet per second. How many seconds are they before they are 72 feet apart? So this one looks similar to my rate problems again. I have one car going 3 feet per second and another car going 5 feet per second. So these are rates, 3 feet per second, 5 feet per second. So that's why it stands out to me as a rate problem. Then I want to know, well, what's the question asking me? It's asking you how many seconds before they are 72 feet apart. And then what else do you know about the problem? You know not only their rates, but that they're going in opposite directions and that you have the distance apart you're looking for. So the cars are starting right here. One's going this way and one's going this way, similar to our trucks going on the opposite ways. I want to know how long before that's 72 feet between them two. The first car is moving at a 3 feet per second, so that's its rate is 3t. The other car is going at a rate of 5 feet per second. So altogether, when you add them up, it'll equal 72 feet. So combine like terms, 8t equals 72, divide by 8, and you get t equals 9. So it will take, I want to go back up and look at my units. It was in seconds, so it'll take 9 seconds for these cars to be 72 feet apart. That's pretty quick. All right, that's all I got. I hope this was helpful. Let me know if you want me to add anything or if it's good to go. Thanks, guys.